Hello, welcome to STL, the 3D Printing and Digital Fabrication Podcast. My name is Scott Rocca.
I'm Basilis.
And joining us today is Manda Raymond.
Hi.
So it's Manda's first time on the show here with us. We're hoping that she'll actually become a regular. If you want to tell us a little bit about yourself.
My name is Manda Raymond. I am an artist and analog fabricator, maybe. I live here in St. Louis, and I'm trying to learn about 3D printing and laser cutting.
Okay, works. Yeah. So, since Manda's here, one of the things that we wanted to talk about was kind of prototype to product process. She has a lot of background with a lot of the more traditional methods of going through and creating things and doing a lot of the traditional casting methods. I've got a little bit of experience in that, but nowhere near as much. And so we were going to kind of go through the steps of going from traditional methods and digital means to an end product. So the first thing was when you create an object, you can use one of the 3D modeling methods that we've talked about in one of our previous podcasts, or you can actually go through and make it in a traditional sense. And one of the ways that you can get that into the digital form is to use a 3D scanner. I know you've seen some of the stuff that we've done before, and we got a couple of scans of folks here that we've printed. Have you messed around with doing any of the lost material castings for plastics?
I know plastic burns out. I've never done it. I've used styrofoam before, which I think is probably pretty similar. It burns out at a really low temp.
Yeah. It's super toxic, but
yeah,
it's like inhaling cancer toxic. But yeah, I know I've seen that used for sprues a lot before. And those who don't know, sprue is one of the pathways that you're going to actually use to go from the exterior of your mold down to the interior where your object is. And there's a lot more to it than that, but that's the simple version.
It makes a tunnel for the metal or whatever you're casting to go through.
Yeah. And one of the ways for going from a traditional piece, whether it's something that was carved or sculpted from wax or clay, what have you, if you check out Make's blog, they actually just had a review of a whole bunch of different scanners that are on the consumer grade market. Another website called Fabaloo reviewed one that 3D Systems is putting out, but that's about $15,000. Whereas a lot of the other ones will run from $1,500 to $500, which is a lot more in the consumer range. And they'll still get some really high quality scans out of them. So let's see here. So have you done much of the modeling with small wax objects, things like that?
Yeah, just basically anything that you can melt or burn out, you can make wax like Play-Doh almost. So it's kind of like baking a Play-Doh form. And then you surround it with something that won't disappear when you, in essence, burn out the wax. You melt it out, sort of, but in order to get a clean cast, you have to get all essence of it. So you have to heat it up to the point that it ignites and gets rid of all the carbon and everything else. That's pretty cool. And the same would be true with plastic. And then you keep that mold hot because you don't want to heat shock it. And you pour molten metal in. You can cast a lot of other stuff though, like anything that can go from liquid to solid, you can cast, like an ice cube or plaster, anything like that. Concrete.
I know one of the videos that I've seen where a guy up in Alaska was actually making a CNC machine, and he needed a part to hold one of his anti-backlash screws. So what he did was he modeled it out in 123D, I think, printed it, and then did a lost PLA casting on it. When he did that, he actually did the burnout on it for about 2 hours, and he just let the thing run. From there, it was a pretty simple process after that, because he actually took an air hose to it and blew it out a bit, because there was some ash still left over. And even though PLA will burn clean, you still have to do a little bit of cleanup in your mold. Yeah.
A lot of times in foundries, you'll see big shop vacs where they sort of clean them out that way.
But he went through and did that, and it was kind of funny, too, because you could see He was getting a little bit worried because he did this outside in the snow, and so he was getting kind of worried about steam explosions.
Yeah, I've seen one of those. They're ugly.
Yeah. Well, he actually went around first with a torch with a burner end on it, and he actually melted all the snow and everything like that around him. For anything that you actually do with a lost material casting that you're going to put metal into, usually you're going to heat the metal. Even if it's just setting it next to the forge or foundry, whatever you're using as your heat, you're going to set it next to that so that it'll help to burn off all the extra water so that you're not going to have an explosion because,
Because even a little bit of water, when you heat it up really, really fast, it goes immediately to steam and causes a really amazing
Sublimates.
pop.
Yes. And, a splash of molten metal going places is not fun.
Yeah.
Because, even in fire gear, it's going to hit you and be a little startling.
It's hot and everything around you catches on fire and everybody starts yelling and it's bad.
Yep.
Yeah, I can imagine. Yeah.
Important part, don't use ABS. Most ABS is made with a fire retardant in it, and it'll turn to slag rather than actual burn. It won't burn out.
It's like if you ever melted a Lego and it just kind of becomes this gloppy molten mess.
Yeah.
That's why it becomes that mess, is because it's actually got a fire retardant in it. And when you see old Legos and they're discolored, it's because the fire retardant has over time basically evaporated away. And so you can soak your Legos in a little solution that you can make from the grocery store.
Yeah.
And it'll put the fire retardant back in the plastics. So then you'll get all the color back.
Yeah, don't use ABS.
That's why they do it for kids' toys, so they don't catch on fire.
Yeah.
It's partly that. But it's also one of those things where it'll extend the life of the plastic and it doesn't get as brittle and things like that.
Okay.
But, kids play with matches. Or
Some kids more than others.
Yeah. So, let's see. So, one of the advantages of doing the scanning is that you can actually see what your end product's going to look like before you go through and do the molding and casting process. And the nice part about actually scanning it before going through and doing that process is that you'll actually have that model in 3D and you can make any modifications or tweaks to it, put it out on Shapeways for other people to buy it even. That's one of the cool things about doing something like that. You can also get a lot more fine touch stuff. So you'll have tool marks or textures that can be applied or part of the process in sculpting that object, which is actually very hard to do in a lot of the programs because, as one of our professors used to say, smooth is the enemy.
Yeah. Smooth is one of an infinite number of surfaces.
Yes.
Infinite! It's kind of boring.
Well, we always used to say that our professor that both Manda and I had, we kind of joked at one point that if he was a superhero, he would be like Captain Texture.
Yeah, that's true. That's true.
Yeah. Can of corn, Marge. Anyway, so you can actually get a lot of those fine tool marks, and it makes it feel a lot more handmade. The nice part about doing something in 3D, though, when you're actually modeling it and going through and doing that process, is that you'll get a nice finished product. It's easily scalable, easily modifiable. It's something that if you need to, you can send that file over to somebody else. They can make modifications to it very easy. That's the nice thing about doing it where you're actually sculpting it in 3D instead of doing a traditional method, scanning it, and then modifying things. You're going to have less steps in between the traditional process of scanning as opposed to the actual modeling process and then going through and prototyping. So from there, you can go through, and we talked a little bit about molding already, but there's different types of molds that you can use for different processes. We have this guy up here, actually, is a silicone mold. It's a food-safe silicone from Smooth On. I've used that to make chocolate bars, of all things, and I actually printed off the positives, molded that, and that gave me the negatives. And so when you're going through and doing these processes, you have to think about how you're going to mold it, especially if you're going from something that you're going to print as your prototype. you want the actual object, or if you can do it with certain programs, you can actually print the mold itself by reversing everything. And that's a whole nother process and pain in the ass talk.
Most CAD programs nowadays that cost several $1,000s have that feature built into it.
Yeah, it's one of the cool things that I love about SolidWorks is you can design something and it can be exactly what you want, and then there's a molding and casting or a molding feature that you can actually just go in and say, hey, I want a mold of that thing that I made.
And it'll build you the mold and take away the object. Awesome.
And you can tell it if you want it to be a single part, multi-part, if it's going to be sand casting, so on and so forth.
You can also choose the type of molding technique, like if it's just you're pouring shit into it or you're doing injection mold or something like that. It's pretty cool.
Yeah.
So because that would depend on what kind of screws and gates and...
And
nice.
I know with SolidWorks there's a FlowWorks, so you can actually see how materials will flow through that mold too.
Make a little jump gaps.
Yeah.
This is a CAD program?
Yes.
Yeah, it's a CAD program. He knows how to do fairly well.
Yeah, it's...
I gotta look that up.
It's a very complex... That's me.
Okay.
It's a very complex and robust program, but it's got a pretty good learning curve to it, and it's a mechanical modeling program.
Okay.
Although I've seen lately coming out of Blue Realm Studios, they've been doing some helmets with it, so that's been pretty cool.
Well, yeah, and anything you do mechanical drawings, you can do art with. You just have to do a little bit different, or you can probably pull up something like Sculptress or ZBrush or anything like that, and combine it with that to also make everything.
Well, even like the casting flow chart. Would be awesome because then you can see how things are going to flow.
You know where your mistakes will be before it even comes out.
Before you even put it in there. Which is bad.
With SolidWorks, it's not necessarily going to be... It'll show you how things will flow and where you're going to have points that things will get stuck. And it's usually assuming that it's going to be a constant flow. So it might not work. I haven't messed around with FlowWorks too much.
But it gives you just another tool. Like with experience and that tool combined, you can probably meet all the issues you're going to find.
Yeah, pretty much. Which is a pretty cool thing. So, I mean, you can do sand casting, lost material casting, depending on what your material is. Injection molding, that's a really cool process, and I really want to build an injection molder at some point, just because.
Future.
Yes.
There was actually a really cool video that they did where they did, like, not PLA, not ABS, polycarbonate. Okay. They printed in polycarbonate, jammed into an injection molder, and then did an injection mold with soft rubbery plastic. Yeah. And it worked pretty nicely. And it was, almost no time from design, print, to injection. And it was a finished product.
Yeah. I mean, it's just getting crazier and crazier with some of the stuff you can do because... And that's one of the things that I liked building my own printer over was that you can modify things so that your machine can take a higher temperature material. So like polycarbonate, you have to run it like 240 C to print.
Yeah, use a Prusa nozzle and stuff like that.
Yeah, you have to use a much higher grade nozzle than some of the stuff you can normally find.
Well, the insulatorless nozzle makes it a whole lot easier to do.
Yeah, it does. But I mean, it's that whole process though. So you have to almost purpose build your hot end just to run those materials. Especially if you're trying to get something really exotic like HDPE or LDPE isn't really as much of an issue because it'll adhere.
Well, most current nozzles will do HDPE. There's just curling issues.
Yeah, and it's one of those things you have to have you have to re-adhere. But I think HDPE would be an interesting one to try and do some molding with because you print the mold and then you actually can
do the injection and then you don't have to worry about the warping because you leave it in the mold until it's cooled.
Yeah. Well, it's not even that though. It's HDPE. Like nothing wants to stick to it. Like bacteria and algae just go like done. It's like they're not gonna stick to it because that was actually part of the way.
The original extruder.
For those of you who don't know, the whole making your own filament thing. One of the things that helped to get that kickstarted was a guy who was basically I'm not sure if he was a botanist, but he liked plants and he worked for a greenhouse. So what he wanted to do was he wanted to make a plastic material that algae could actually grow on in water so that he could use that for doing some hydroponic stuff. And he made this little filament machine and it kicked out HDPE and it was just chopped up milk jugs and he put a knurled little piece of metal on there and it would texture it. Well, the problem was algae would start to grow in those knurlings, but then he could just pick the bottle up and our bucket that he had everything and shake it, all the algae would come loose. So HTP.
So he could harvest it.
Yeah. Well, no, that's so he could harvest it because he wanted it to adhere to that stuff.
Oh.
Because he was trying to grow the algae on purpose.
Okay.
The problem,
so it didn't do what he wanted.
No.
But he could harvest it.
Exactly. If he wanted to, he could harvest it really easily.
Just turn it into a green water bucket.
HDPE.
Yeah.
Milk jug.
High density polyethylene.
Early days when we first kind of knew each other, Scott was collecting like truckloads
of milk jugs.
And then hand shredded them, and then I have no idea. Do you still have those?
No, I recycled them.
Oh.
Very good.
Yeah. That was a pain in the ass process. But I work for a grocery store chain right now, and back when I was collecting all that stuff, I was working in our dairy department. And when I would go and stock the shelves and stock all the milk jugs, fairly often, because these things are blow molded, you would get these little plastic bucks and just these little oval shaped pieces, and they were pure plastic. And it was because of the molding process. You're knocking out thousands and thousands of these things. There's going to be a couple little defects from that. And then it was that, and then any of the milk jugs that burst or milk went bad. I'd clean them out at work. We'd mark them as damaged. Normally we'd throw them out. So I would just, I'm taking them home. I'd walk home. I'd like every week I'd go home with like another 25 or 30 milk jugs because they all got damaged.
Yeah.
And it's like, well, you can't really give this milk away because it's leaking everywhere.
Yeah.
So it's like, I'm going to go pour this out and wash it out, damaged, take it home.
But yeah, good point about that is, though, you're recycling it locally.
Yeah.
As soon as you have it, you'll have the material to be used constantly for different things. You can upcycle it to products that will last, like, instead of a milk jug that's useful for a week, that product could be useful for like years and years to come.
Yep.
So that's a good thing about having that locally.
Yeah. One of the cool things I did find out, though, is that LDPE is actually something that plastic grocery bags, things like that, are made of. And you can take that LDPE, combine it with some machinable wax, and if you heat it and do everything right, you can make more machinable wax out of plastic bags. So
because those have a really low melting temperature.
Exactly.
Like
that's LDPE.
A low iron and some wax paper, and you can make an amazing fabric.
Oh yeah. Well, it's low density polyethylene,
Yeah.
so it's low density and high density, and like the tops for all the milk jugs are low density.
Oh.
So, one of the things that I was actually trying to do at one point was Starbucks on campus. They actually had, or they would go through several trash cans of milk jugs per day for all their coffee, and they just throw all this shit out. And I actually went to them. I was like, if I had a way to give you a trash can with a grinder in it, and you wouldn't gnarl your fingers up, would you use it? Because then I could take all this plastic and do something with it.
Yeah.
They're like, oh yeah, sure, fine. I figured it out. I would have to sit there all day for as long as they were open, and every 4 hours I would have to go and empty this trash can because they used that much plastic. So then,
well, wouldn't like one of the paper shredders that can also shred CDs work?
If they can,
we're looking at that.
We're working on that. The problem with that, though, is that you run into issues where you actually have to shear the plastic. It's not just that you're cutting it up. You actually have to do a shearing motion to get it to a consistent small size that can go back through one of these machines that'll turn it into either filament or whatever. If you're doing injection molding, that doesn't matter as much.
Yeah.
Because you can just sit there and let the thing heat until everything's consistent.
Yeah, you're making it into liquid and just pushing it through.
Yeah. But if you're trying to do filament to print a mold, that's when you run into issues.
So the filament maker you were working on.
Yeah.
Yeah. Well, I have one, and if I do any more exotic stuff.
Could you do the milk jug plastic with it if you got enough?
Yeah.
Oh yeah, easy.
You just have to shred it by hand.
Yes.
Chunk it by
currently.
hand.
Yeah.
Okay.
Which is easier than it sounds as long as you have a decent pair of scissors.
But yeah, I'll sit around and watch Netflix and shred milk cartons for you. Whatever, I'm game.
You know, after
if nothing sticks to it, I really want to try this.
The thing I'll say that you'll get this one is plastic bag sheep.
I know.
You remember that madness?
Yes, I do remember the plastic bag sheep. Did you ever see these? They were on campus.
I went to sleep.
Yeah.
Oh, never mind.
A friend of ours made sheep out of plastic grocery bags that I actually got for her. And there are pictures in her apartment of just
sort of like that, but
piles of thousands and thousands of plastic bags that she'd cut up. And a couple of them she actually laminated into a dress even.
Yeah, she made a plastic bag dress. Because it does, plastic grocery sacks make an amazing material. It's like waterproof and it's soft and you make it like 4 layers thick and it's super durable. You can sew it, you can...
I've made dress forms with it actually. So I would do a saran wrap and packing tape process of actually cheapo molding myself. And you can stuff that with plastic grocery bags and then you can control the density of your armature, which is actually really cool.
Yeah, because then you can pin into it and...
Yeah. One of the other cool things with that, though, is I figured out if you coat it with Plastidip, it will get rid of the tape texture.
You know, I'm going to remember that one, too. I got to start making those same dress forms.
But, yeah, that was one of the things I was playing with because I actually wanted to make a hand and put some animatronics in it. And I wanted it to look like my own hand, but I wanted to do it on the cheap. And I figured out, if I paint Plastidip on here in enough thin layers, it'll slowly take that texture away.
Latex probably would too.
Latex will work, but it's not going to be as durable because Plastidip's made for tool handles.
True.
So,
you just bad joke.
I already know it.
I don't, and I don't think I want to.
Things you use liquid latex for. Anyway. So just to do a quick recap, you can produce something through traditional means, or you can model it in 3D. If you're using the traditional process, scan it, then mess with it, scale it up, scale it down, do whatever you need to. Put a trademark inside of it, like one gentleman did on Thingiverse. Something like that. You
can't see it, but it's there.
You can do that kind of thing. You can do tons and tons of different casting methods. Check out Smooth On. It's smooth-on. Just toss them into Google. They have thousands of videos on how to use their products, how to use all kinds of awesome stuff. Check out injection molding.
They also have really helpful customer service people. So if you have a question about something you want to do, call them, and they're awesome.
Yeah. The thing I always tell people, if you want to mold a dead cat, you can call them up and be like, how do I make a mold of this without taking the hair off the cat? And they will tell you.
I want to make a mold of a dead cat that I want to cast in platinum. They'll still know how to do it.
Yeah.
So.
Yeah, they're crazy, crazy, awesome people. But if you guys have any questions, please leave them in the comments below. We'll do the best we can to answer. Thanks for joining us. My name is Scott Rocca.
I'm Bassus.
I'm Manda.
And yeah, have a good night.